Welcome to Sciencera. In this video, we're going to discuss resistance of body to the infection, which mean your immune system. This is chapter number 34 from Guyton's and Whole Medical Physiology. Let's begin. We know that our body have a special system which combine and fight with different infections and toxic agents. This system consists of your white blood cells, which are known as your leukocytes, and some types of tissue which are also derived from the white blood cells. These cells together work together in two ways to prevent disease: by actually destroying invading bacteria's viruses by phagocytosis, or by forming antibodies and sensitized lymphocyte that may destroy or inactivate the invaders. Leukocytes are your white blood cells and are the mobile units of your body's protective system. These formed in the bone marrow, known as granulocytes and monocytes, and few are lymphocytes. And some of the leukocytes are formed in your lymph tissues. Those are known as lymphocytes and the plasma cells. General characteristics of leukocytes includes: there are six type of your white blood cells, which are polymorphonuclear neutrophils, polymorphonuclear eosinophils, basophils, monocytes, lymphocytes, and occasionally occurring plasma cells. The first three types of cells are the polymorph nuclear cells, all have the granular appearance. For this reason, they are known as granulocytes. These are your polymorphonuclear neutrophils, polymorphonuclear eosinophils, and polymorphonuclear basophil. The granulocytes and monocytes protect the body against invading organisms by ingesting them. This process of ingesting your invaders or foreign organisms are known as phagocytosis. The lymphocytes and the plasma cell function mainly in connection with your immune system. So all of these cells work together to form your immune systems and protect your body. Here in the table you can see that the percentage is given about how much of a percent is found of neutrophils. Polymorphonuclear neutrophils are found 62.0%. Eosinophils are found 2.3% in the body. Basophils are 0.4%. Monocytes 5.3%, and lymphocytes is 30%. So these are neutrophils. Polymorphonuclear neutrophils and lymphocytes are found in higher concentration in your body as compared to the other cells. Next is the genesis of white blood cells. Aside from the cells committed to form RBCs, two major lineage of WBCs are formed. These are known as myelolytic and lymphocyte. Here on the screen you can see the diagram which represents the genesis of white blood cells. You can see that this genesis is divided into two lineage, which is genesis of myelocytes and genesis of lymphocytes. Genesis of myelocyte begin with myoblast, which divides to form megakaryocytes and promyelocytes. In this stage, the myelocytes will develop, then metamyelocytes will form, band neutrophils will form, and then you will have a neutrophils. Here, from genesis of myelocyte, neutrophil, eosinophil, basophils, and monocytes will be formed. The granulocytes and monocytes are only formed in bone marrow. Lymphocytes and plasma cells are produced in various lymphogenous tissues like lymph glands, spleen, thymus, tonsils, etc. White blood cells formed in the bone marrow are stored within the marrow until they are needed in the circulatory system. Lymphocytes are mostly stored in various lymphoid tissues, except for a small number of a temporarily being transmitted into the blood. Lifespan of white blood cells. The life of granulocytes after being released from the bone marrow is normally from up to 4 to 8 hours circulating in the blood and another 4 to 5 days into the tissues. Monocytes as compared to other cells, monocytes as compared to the granulocytes have short transit time up to 10 to 20 hours in the blood. Once in the tissue, they swell to much larger size to become tissue macrophages, and in this form they can live for months unless they are destroyed. These tissue macrophages are the basis of tissue macrophage system, which we will discuss later on. Lymphocytes enter the circulatory system continually along the drainage of lymph from lymph nodes, other lymphoid tissues. After a few hours, they pass out of the blood back into the tissue by diapedesis. Then they re-enter the lymph and return to the blood again and again. Thus, there is a continual circulation of lymphocytes through the body, and lymphocytes have a lifespan of about a week or a month, depending on the needs of the body, where the body needs lymphocyte and for how long they need it. The platelets in the blood are replaced about once every 10 days. Then we have neutrophils, macrophages, and defend against the infection. The neutrophils are the mature cells that can attack and destroy bacteria even when circulating in the blood. The tissue macrophage begins being live as blood monocyte, which are immature cells while still in blood and have little ability to fight infectious agent at the time. White blood cells enter the tissue space by, as we said, diapetesis. Neutrophils and monocytes can squeeze through the pores of blood capillaries. These squeezing of neutrophils and monocytes through the blood capillaries are known as diapetesis. White blood cells move through tissue spaces by amoeboid motion. Both neutrophil and macrophage can move through the tissue by amoeboid motion. Here you can see increased permeability, merigation, and diapetesis. White blood cells are attracted to inflamed tissue areas by chemotaxis. Many different chemical substances in the tissue cause both neutrophils and macrophages to move towards the source of the chemical. This phenomena is known as chemotaxis. What happened is they include some of the bacterial or viral toxin, degenerative products of inflamed tissue, several reaction product of complement complex, and several reaction product caused by plasma clotting in the inflamed area as well as the other substance. So this diagram summarizes the chemotaxis substance, diapedesis, merigation, and the increased permeability. Next concept we going to discuss is phagocytosis. Phagocytosis must be selective of the material that is phagocytized. Otherwise, if it is not selective, normal cell and structure of the body might get ingested too. First, the most natural structure in the tissue have smooth surface which resist phagocytosis. However, the surface is rough. The likelihood of phagocytosis is then increased. Second, most natural substance of the body have to have protective protein coats that repel the phagocytes. Conversely, most dead tissue and foreign particles have no protective coats which make them the subject of phagocytosis. Number 3, the immune system of the body develops the antibodies against the infectious agents such as bacteria. These antibodies then adhere the bacterial membrane and thereby make the bacteria specially susceptible to the phagocytosis. The process by which a pathogen is selected for phagocytosis and destruction is called opsonization. The neutrophil first attaches itself to the particles and then projects uh, pseudopodia in all directions around the particle. The pseudopodia meet one another on the opposite side and fuse. Phagocytic vesicles are known as phagosomes. A single neutrophil can usually phagocytize 3 to 20 bacteria before the neutrophil become inactive and die. Phagocytosis of macrophages. They are much more powerful phagocytes than the neutrophils. They are often capable of phagocytizing as many as 100 bacteria. Also, they have the ability to engulf larger particles, even a whole red blood cells. Macrophages can extrude the residual products and often survive and function for many months. Once the foreign particles have been phagocytized, lysosomes and other cytoplasmic granules in the neutrophil or macrophage will immediately come in contact with the phagocytic vesicle, and their membrane will fuse and become a digestive vesicle. Both neutrophils and macrophages contain an abundance of lysosomes filled with proteolytic enzyme, which is specially geared for digesting bacteria and other foreign matters. Lysosomes of macrophages also contain large amount of lipases, which will digest the thick lipid membrane processed by some of the bacteria. Neutrophil and macrophages can kill bacteria. They contain bactericidal agents that kill most bacteria even when the lysosomes enzyme fail to digest them. Some bacteria have protective coat. Much of the killing effect results from the several powerful oxidizing agent formed by an enzyme in the membrane of phagosomes or by a special organelle called peroxisomes. What happens is these oxidizing agents will include large quantity of superoxides, hydrogen peroxide and hydroxyl ion, which are lethal to most of the bacteria. Monocyte-macrophage cell system, which is also known as reticuloendothelial system. Other foreign particles in the tissue, in addition, when appropriately stimulated, they can break away from their attachment and once again become mobile macrophages that respond to chemotaxis and all other stimuli related to the inflammatory process. Thus, the body has a widespread monocyte macrophage system in virtually all the tissue areas. The total combination of monocytes, mobile macrophages, fixed tissue macrophages, and a few specialized endothelial cells in the bone marrow, spleen, and lymph node is called the reticuloendothelial system. Tissue macrophage in the skin and subcutaneous tissue are known as histiocytes. You can see the functional diagram of lymph node. The particles are not destroyed locally in the tissue. They enter the lymph and flows to the lymph node. Foreign particles are then trapped in these nodes in a meshwork of sinuses lined by the tissue macrophages. Lymph entering through the lymph node capsules by a lymph enter the lymph node capsules by the way of efferent lymphatics, then flowing through the nodal medullary sinuses and finally passing out to the hilus into the efferent lymphatic that eventually empties into the venous blood. So its lymph travels from efferent to medullary sinuses and to the efferent lymphatics. Large number of tissue macrophages are present in integral components of alveolar walls. If the particles are digestible, the macrophages can also digest them and release the digestive product into the lymph. If the particle is not digestible, the macrophages often form a giant cell capsule around the particle until such capsules are frequently formed around tuberculosis, bacilli, silica dust particles, and even the carbon until it can be slowly dissolved. Macrophages, also known as Kupffer cells in the liver sinusoids, before this blood enters the general circulation. It passes through a liver sinusoids, which are lined with tissue macrophages called Kupffer cells. Almost none of the bacteria from the gastrointestinal tract pass from the portal blood into the general systematic circulation. Macrophages of spleen and bone marrow. If an invading organism succeed in entering the general circulation, there are other lines of defenses by tissue macrophage systems, especially by the macrophages of spleen and bone marrow. In both of these, macrophages become entrapped by a reticular network of two organs. The spleen is similar to the lymph node except that blood instead of lymph flow through the tissue spaces of the spleen. This peculiar passage of blood through the cells of the red pulp provides an exceptional means of phagocytizing the unwanted debris in the blood, including specially cold and abnormal RBCs. Old and abnormal RBCs. Then we have inflammation. Here you can see the functional structure of spleen with pulp, capillaries, venous sinuses, vein and arteries labeled. Next is inflammation, role of neutrophils and macrophages. Inflammation is characterized by first vasodilation of local blood vessels with consequent excess local blood flow, increased permeabilities of capillaries, clotting of the fluid in interstitial space, which increase the amount of fibrinogen, and other protein leaking into the capillaries. Number 4 is migration of large number of granulocytes and monocytes into the tissue. And number 5 is swelling of tissue cell. Some of the many tissue products that cause these reactions are the histamine, bradykinin, serotonin, prostaglandin, reaction product of the complement system, reaction product of the blood clotting system, and multiple substances called lymphokines. Walling off effect of inflammation. One of the first results of inflammation is to wall off the area of injury from the remaining tissue. The intensity of inflammatory process is usually proportional to the degree of tissue injury. For instance, staphylococcus release extremely lethal cellular toxin. As a result, inflammation develops rapidly. Local staphylococcal infection is characteristically walled off rapidly and prevented from spreading through the body. Streptococci, in contrast, do not cause such intense local tissue destruction. Streptococci often have a far greater tendency to spread through the body and cause death, and then do the staphylococci. Even though the staphylococci are far more destructive to the tissue. Macrophages and neutrophil response during inflammation. Tissue macrophages provide a first-line defense against infection, which is within minutes. After inflammation begins, macrophages are already present in the tissue. Neutrophil invasion of the inflamed area is the second-line defense. This happens within the hour. Large number of neutrophils will begin to invade the inflamed area from the blood. This invasion is caused by the inflammatory cytokines. For example, one of the inflammatory cytokine is the tumor necrosis factor and other one is interleukin 1. Other biochemical products produced by inflamed tissue will initiate the following reaction. Number 1, they cause increased expression and expression of adhesion molecules such as selection and the internuclear adhesion molecule on the surface of endothelial cell reacting with the complementary integrin molecule of neutrophil, which is called the merination. Number 2 is they also cause intracellular attachment between the endothelial cell of the capillaries and small venules will loosen up. Look at the diagram. This diagram here represents the migration of neutrophils from the blood into the inflamed tissue. Cytokines and other biochemical products of the inflamed tissue cause increased expression of selection and intercellular adhesion molecule, which is CAM1 in the surface of endothelial cell. These addition molecule will bind to the complementary molecule or receptor on the neutrophil, causing it to adhere to the wall of capillary or venule. The neutrophil then will migrate through the vessel wall of by diapetesis through the site of injury. So here you can see selection. These are the receptor and selection is occurring. Neutrophils are produced. They are moving through diapedesis into the inflamed tissue, and these are the cytokines. Four-step process is rolling addition, tight binding, diapedesis, and migration. Step number 3 is they can also cause the chemotaxis of neutrophils towards the injured tissue. They are ready to immediately begin their scavenger function of killing bacteria and removing the foreign matter. Within acute increase in number of neutrophils in the blood is known as neutrophilia. Also within a few hours after the onset of acute severe inflammation, number of neutrophils in the blood sometimes increase. Second, macrophage invasion into the inflamed tissue is a third line of defense. Also, the storage pool of monocytes in the bone marrow is much less than that of neutrophils. Therefore, the buildup of macrophages in the inflamed tissue area is much slower than that of neutrophils, requiring several days to become effective. After several days or weeks, the macrophage finally come to dominate the phagocytic cell of the inflamed area. Macrophage can phagocytize far more bacteria and particles. Increased production of granulocytes and monocytes by bone marrow is the fourth line of defense. This results from stimulation of the granulocytic and monocytic progenitor cells of the bone marrow. Next is the control of bone marrow production of the granulocytes and monocytes. Macrophage response to the multiple growth factor. Multiple growth factors released from the from activated macrophages in a inflamed tissues are TNF, granulocyte monocyte colony stimulating factor, granulocyte colony stimulating factor, monocyte colony stimulating factor. Formation of pus. When neutrophil and macrophage engulf large number of bacteria or necrotic tissue, if not most of the macrophage eventually, especially all the neutrophils and many, if not most of the macrophages will eventually die. After the several days, a cavity is often excavated in the inflamed tissue. This cavity will contain varying proteins of necrotic tissue, dead neutrophils, dead macrophages, and tissue fluid. Eosinophils. Eosinophils contain about 2% of the blood leukocyte. Eosinophils are weak phagocytes. Doubtful that eosinophils are significant in protecting against the usual types of infection. These attach themselves to the parasites by the way of special surface molecule and then release substance that kill many of the parasite. Eosinophils attach themselves to the univile forms of parasite and kill many of them by do so in several ways. Number one is by releasing hydrolytic enzyme which are from their granule which are modified lysosomes, probably by also releasing high reactive forms of oxygen that are especially lethal to parasites by releasing from the granules a highly larvicidal polypeptide called major protein. Eosinophils also have a special propensity to collect in tissue in which allergic reaction can occur. The mast cell and basophil release eosinophil chemotactic factor that cause eosinophil to migrate towards the inflamed allergic tissue, thus detoxifying some of the inflammation. And basophil and also probably also phagocytize and destroy allergy antibody complexes, thus preventing excess spread of the local inflammatory process. Basophil in circulating blood are similar to the large tissue mast cells located immediately outside many of the capillaries. Both mast cells and the basophil liberate heparin into the blood, also releases histamine as well as smaller quantities of bradykinin and serotonin. Mast cells and basophil plays an important role in some types of allergic reaction. In the immunoglobulin E, IgE type has a special propensity to become attached to the mast cells and basophils. Leukopenia. It is a condition where bone marrow produces very few white blood cells. This condition leaves body unprotected against many bacteria and other agents that might invade the tissue. Another kind of disease is leukemias. Uncontrolled production of white blood cells is known as leukemia and can be caused by the cancerous mutation of myelogenous or lymphogenous cells. Two general types of leukemia are the lymphocytic and myelogenous leukemia. The lymphocytic leukemias are caused by the cancerous production of lymphoid cells beginning in the lymph node or the other lymphoid tissue and spreading to the other areas of the body. Myelogenous leukemia begins with cancerous production of young myelogenous cells in the bone marrow, and then they spread throughout the body so that white blood cells are produced in many extramedullary tissue, especially in lymph nodes, spleen, or liver. Myelogenous leukemias, the cancerous process, occasionally produce partially differentiated cells which result into the um, neutrophilic leukemias, eosinophilic leukemias, basophilic or monocytic leukemias. Usually, the more undifferentiated the cell, the more acute is the leukemia. Leukemic cells, especially in very undifferentiated cells, are usually the non-functional for providing normal protection against the infection. What happened to the body in leukemia? The first effect of leukemia is metastatic growth of leukemic cell in the abnormal area of the body. Leukemic cells from the bone marrow may reproduce so greatly that they invade the surrounding bone, causing a tendency for bone to become fracture easily. Common effects of leukemia are the development of infection, severe anemia, and bleeding tendency caused by thrombocytopenia. Us to the end of chapter 34 of immunity. Thank you for watching. If you like my video, don't forget to subscribe for more.